Hi everyone, welcome back to my number sense series. In this video, we're going to do our first geometry problems. So with geometry, we're going to be kind of diving into the deep end here. We're going to be talking about interior and exterior angles. But when I say diving into the deep end, I don't mean that we need a ton of foreknowledge. In fact, we really only need to know, what an angle is, what shapes are called, and basic knowledge about how to measure angles, and one fun fact about triangles. So let me talk about interior and exterior angles first. First, what even are they? Well, an interior angle is what we typically think of when we hear angle. For example, if I have a pentagon here, this is an interior angle. It is inside of the pentagon. It is formed by two sides of the pentagon, and that's why we call it an interior angle. However, we also have things called exterior angles. Those are things, as you can infer, outside of the hexagon, exterior to the pentagon, exterior to the pentagon. And those would be formed by one side and another side that is being extended. So this would be an exterior angle, for example. So with that said, how do we measure them? Well, in number sense. When they give you a problem about a shape, they're always going to say that it is a regular shape. And a regular shape is something where all the angles and all the sides are equal. So here, imagine that all of these angles are equal and all of these sides are equal. They might also give you, a square, a triangle that may look like this, maybe a hexagon that looks something like this. These would all be regular shapes. Their angles are all the same. I tried to draw them like that, and their side lengths are all the same. And that is the important thing that lets us calculate what exactly each angle is. Because, all the angles are the same. So, what are they? Well, the first thing that we should calculate is the sum of the interior angles, actually. This problem right here. This actually turns out to be both the easiest and the most important. So let's kind of get on with that. And we have to look for a pattern, kind of. There's a formula, but I want to motivate the formula. So let's start with a triangle. The sum of the angles in a triangle is 180 degrees. This is the fun fact I was talking about. The sum of the angles in a triangle is 180 degrees, and that's all we need to know. Because now let's look at the sum of the angles in a square. We want to add these four angles. But instead of looking at it as a square, think of it as two triangles. Then what we have is this angle plus this angle plus this angle. This equals 180. This plus this plus this equals 180. So if we add all of these angles together, all six of these angles together, they make the four angles of this square. And in total, they combine to make 360. Very nice. Now, similarly, if we think of a pentagon differently, what we can think of it as is three triangles. Now, this triangle has sum 180, this is 180, and this is also 180. So a pentagon is actually 180 times 3, which is 540. And similarly, a hexagon, it's just four triangles. So 4 times 180 equals 720. And hopefully here you are noticing a pattern. 180, 360, 540, 720. Each time we add 180 degrees to, the sum of the interior angles of a regular polygon. That's what we're doing. We're summing all the interior angles right here. And so the formula explicitly is going to be 180 times n minus 2, where n is the number of sides that we have. So for example, if n equals 3, we'd have a triangle, and we'd have 3 minus 2 equals 1, 1 times 180 equals 180. If we had n equals 6, we would have 6 minus 2 equals 4, 4 times 180 equals 720, 4 triangles. So that is how we motivate that. Okay, well then, once we have the sum of all the interior angles, finding the interior angle is very easy, right? The interior angle is going to simply be this divided by n, because we have n interior angles, they are all the same, and they all add to 180 times n minus 2. So if we divide this by n, we'll get that the interior angle, so interior equals 180 times n minus 2 over n. Well, our last step is to solve for exterior angles. And actually, we don't have to do anything else here because we almost have it already. See, an interior angle and an exterior angle are actually related, right? interior, exterior. If you add them together, what do they form? They form a straight line 180 degrees. So if I write all interior plus all exterior, right? If I add every interior angle together and I add every exterior angle together, I get 180, 180, 180, 180, 180. I have n times 180, right? Or 180n. But I know that the sum of the interior angles is 180 times n minus 2. In other words, 180n minus 360. 180n minus 360 plus all the exteriors equals 180n. Well then, all the exteriors must be equal to 360. That's a very, very nice result. And this is my favorite result in this video. The sum of every exterior angle is 360. And in fact, this proof actually works for like every polygon, basically. It doesn't have to be regular, but number sense won't test you on that. So just know this. The sum of every exterior angle, that is this plus, this plus this plus this plus this. All of that equals 360, always. Then, if I want to just find one exterior angle, same process, I have n exterior angles, they are all the same, and they all add to 360. So, each exterior angle is 360 over n. For example, if n equals 5, we have a pentagon, and the exterior angle is 72. If I have a square, n equals 4, and the exterior angle is 90, or a right angle. If I have n equals 6, I have a hexagon, and the exterior angle is 60. And now, with all of that out of the way, we just have one more thing to talk about. And that is shape names. Now, number sense is not going to tell you how many sides a shape has. They want you to basically memorize some shape names. The common shape names, and I have listed all of them right here, 3, 4, 5, 6, 8, 9, 10, and 12 sides are the ones that they are going to expect you to know for this kind of problem. Because these are all small numbers that are factors of 360. That's basically why. And so just remember, triangle, quadrilateral, penta. So, if you know kind of how these words work, you'll know 3, 4, 5, 6, 8, 9 is nonagon, 10 is decagon, so deca means 10, and then 12 is dodecagon, so this do means 2, deca means 10, 2 plus 10 equals 12 sides. This is how you kind of remember it, or you can just memorize it. So memorize these shape names, know this, and now we can get into the problems. But of course, once we know the formulas, the problems will be very easy. So hopefully this is rewarding for you guys who have stayed until now. The interior angle of a regular octagon is blank. So once again, the important part is that the octagon is regular, right? That makes it so that we can actually solve the problem. So the interior angle of a regular octagon. Well, we have a formula for the interior angle, so let's try that. That would be 180 times n minus 2 over n. That equals 180 times 6 over 8. And once we compute that, we'll find that the answer is 135. But this is not my favorite way to do this at all. In fact, I don't recommend doing this. Because instead of doing this fraction, what we can do instead is find the exterior angle and then subtract. The exterior angle formula is way easier. It's just 360 over n, right? 360, this never changes. So all you have to know is 360 over n. 360 over 8, that's 45. And now I know interior plus exterior equals 180 always, because this is a line. That's how an exterior angle is created. So interior plus 45 equals 180. Interior must equal 135. Maybe that seemed like a little bit more work to you, but to me, it's a lot easier. Basically, this formula can also be described as 180 minus 360 over n. That's basically what I just did. This is a much better way to write the formula. Okay, let's move on. The sum of the interior angles of a regular hexagon is blank. Well, actually, I have already done this problem over here, but pretend you don't know this, and think about the formula. The formula is n minus 2 then times 180. N is the number of sides. A hexagon has how many? 6 sides. So it's 6 minus 2 times 180 equals 720 degrees. And of course, if you forget the formula, you can try to visualize this in your head. Draw a hexagon. Make the triangles. How many triangles are there? 1, 2, 3, 4 triangles. Each triangle has sum 180. So 4 times 180, that's the total sum of every angle is 720. That's how you can kind of do that in an emergency. Okay, next question. The exterior angle of a regular dodecahedron is blank. I'm not going to lie, the hardest part about this problem is remembering what a dodecahedron is. Once you remember that, you're done. Because the exterior angle, each exterior angle, remember, is just 360 over n. It's just a division problem. What's 360 over n? And, the hardest part is figuring out what n is. How many sides does a dodecahedron have? Well, deca means 10, do means 2, 2 plus 10 equals 12 sides, that you can kind of figure it out that way. Or, I would recommend just memorizing it. The more you see these shapes, the more your brain is going to naturally remember what they are. So even if you don't necessarily memorize them right now, once you do a few problems with each kind of shape, I think your brain is going to just naturally recall by instinct what each shape is. So this has 12 sides. So our answer is just going to be 360 over 12. That is super easy. It is just 30 degrees. Last question. A quadrilateral has 4 angles measuring 64, 64, 142, and blank. So this is not interior and exterior angles, but this is also a special kind of problem that I don't think deserved its own video. Because what this uses is the fact that the sum of the angles in a quadrilateral is 360 degrees, which again is another thing that we showed right here, right? If you divide a quadrilateral into just 2 triangles, you can see that the sum of all the angles is just going to be 180 plus 180, which is 360. So knowing that, we have 64 plus 64 plus 142 plus x equals 360. And now it's a very simple game that many of you have played before. Solve for x. But even if you don't know what x is, you can kind of understand what this question is asking. These 3 plus this something else equals 360. So what I like to do is add these first and then subtract them together all at once. 64 plus 64 plus 142. 64 plus 64, that's 128. Plus 142, that makes 270. So I know 270 plus some other angle equals a total of 360. And so that some other angle is 360 minus 270 equals 90. A perfect right angle. Of course, it's a coincidence, but it's nice. 90 degrees. Always right degrees, kids. Always right degrees. So that is interior and exterior angles. I know this is a lot of information to dump in one video, but this is very, very fundamental to not only number sense, but studying geometry in particular, actually. If you plan to do competitions, maybe in the future, maybe right now, like the AMC 8, AMC 10, AMC 12, AMY, those kinds of questions, you need to know this as well. Interior and exterior angles, super basic knowledge, super important. And hopefully, by remembering these, you'll find out that it's not too hard to understand. It's not too hard to memorize. And if you ever feel like you forgot everything, what I like to do is remember this. I love this fact. The sum of every exterior angle is 360 degrees. And so each exterior angle is 360 over n. I love that fact. So when in doubt, remember this. If possible, remember all of it. And yeah, that's going to be it. Remember how these shapes are divided into triangles, because that is the most fundamental thing about how these work. Practice these problems. Hopefully memorize your shapes. And that's it for this kind of problem. So thank you guys for watching, and I'll see you next time.